Section 6.6 example 2 says let f of x equal x squared minus 9 and g of x equal x plus 3. What are f times g and f over g and their domains? For f times g of x, we just multiply f of x times g of x, where f of x is x squared minus 9 and g of x is x plus 3. To multiply these two binomials, we can use the box or FOIL. When you multiply using the box or FOIL, you'll end up with x cubed plus 3x squared plus 9x minus 27. For f divided by g of x, we have f of x divided by g of x, so x squared minus 9 divided by x plus 3. X plus 3 is as simplified as we're going to get, but x squared minus 9 can be factored. So you can use the x method. Since we just have a 1 as our coefficient for x squared, you don't need the box, you can just do the x. And a times c will give us negative 9. We're missing our b, so that is 0. 3 minus 3 is 0. 3 times negative 3 gives us negative 9. So x squared minus 9 becomes x plus 3 times x minus 3 all over x plus 3. We can simplify x plus 3 over x plus 3 to become 1, and we're left with just x minus 3. However, I highlighted the x plus 3 in red because it's in the denominator of our fraction. We aren't allowed to let the denominator equal 0, so we have x minus 3 where x cannot equal negative 3. As far as the domains go, the domain of both f and g, the original functions, is the set of all real numbers. We can plug anything we want into x squared minus 9 and x plus 3. So the domain of f times g, up here, is also the set of all real numbers. The domain of f divided by g, however, is the set of all real numbers except that x equals negative 3. So we can't allow x equals negative 3 to be in our domain, because if we plug in negative 3 to g, we get 0. The work for this problem is written out on the next slide, followed by the explanation of the domains. One final thing I would like to point out about the domains, this last little sentence here says, the definition of f over g requires that you consider the 0 denominator in the original expression for f of x over g of x, despite the fact that the simplified form has the domain all real numbers. So notice our final answer for f over g of x is x minus 3. That has a domain of all real numbers. However, f over g of x does not have a domain of all real numbers. So you need to consider the original f over g of x before it is simplified. Now I would like you to try number 4. Let f of x equal 7x plus 5 and g of x equal x squared. Perform each function operation and then find the domain of the result. We have f divided by g of x.